Good day, guys. Welcome to Rail Engineering Mechanics. Here is a question on moment of force, and the question says the wire AE is stretched between the corner A and E. This is A, this is E, of a bent plate, knowing that the tension in the wire is 435 Newton. So let's write the tension out. Tension is 435 Newton. Then the question says determine the moment about to of the force exerted by the wire A on corner E. So this particular dot here is our corner E. So since I've already write the force, so we are determining the moment about this particular about O of the force exerted on by the wire on corner A. So we are determining the force the moment about this particular corner. So let me bring this particular thing out. So let's erase this question for us to have a better view of this particular thing. So now as you can see, we are determining the moment about this. So don't forget that this particular tension, since it is going from A to O, so that means our force, our tension is acting in this particular direction from A to E. So that's how our tension is acting from A to E. So we can express this our tension in unit vector notation, although we know our moment about point O is equals to the position vector cross the force or the tension. Don't forget, in this case we are using tension AE, the unit vector of this, and the vector notation of this tension. So we can actually express this tension AE in vector notation. So we say this is TAE, which is equals to TAE, the magnitude of the tension, dot the position, the unit vector of the position AE. So that means in this case we'll be having TAE to be equals to the vector notation of this 435 dot open bracket AE over magnitude of AE. This is a position. So 435 dot. So now let's check from A to E. So that means from A to E, firstly we go in this particular direction, also in this direction, and then lastly we come in this direction. So that means we are converting everything to meter. So that means we divide each value by 1000. So from here to here we are going towards the negative of y. From here to here towards the negative of z. Towards the positive of z. And from here to here we are heading towards the positive of x, because for x we are coming in this direction. So that means we are moving towards x, since our x is here. So that means we are having 90 plus 2 on 120, which is the same thing as 0.21 in meter in I direction. 0.21 in I direction. Then also we know from here to here, so that's 0.16 minus 0.16 in j direction, then plus 0.12 in k direction, all over the magnitude of this, which is equal to square root of 0.21 square plus 0.16 square plus 0.12 square. So that means we know our TAE. That means we have this, which is 435 dot open bracket 0.21 in I direction minus 0.16 in j direction plus 0.12 in k direction over. So let's calculate the magnitude of this, which is 0.21 square plus 0.16 square plus 0.12 square, which is square root of this, which is 0.29. So having 0.29, so that's 435 divided by answer. That means we are having 1500 into bracket 0.21 in I direction minus 0.16 in j direction plus 0.12 in k direction. That means we are having this. So that means our tension AE in unit vector notation, sorry, in vector notation rather. So that means we will be having 1500 times 0.21, which is 315 in I direction, minus 0.16 times 1500, which is 240 in J direction, 0.12 times 1500, which is plus 180 in K direction. Now, as you can see, we've actually expressed this particular force in vector notation. So now, but the question is asking us to calculate the moment about this point O. Now, there is actually two ways in which we can calculate this. Now, the first thing is we pick any point. Now, don't forget that this is where our tension is acting. We can already see that this is where our tension is being acting from A to E. As you can see, if our vector, if the tension is being acting in this direction, so that means the line of action of this particular tension is also in this direction. Are you with me? So the line of action of this particular tension from A to E is also in this particular plane direction, like this. So that means for us now, so now this is how we now go about calculating the moment. So we pick any point. We pick any point. Don't forget the question asks us to use point O. So that means we are taking this particular point. So that means we are taking point O as our reference point. So we pick point O. Then the next thing we do is we connect it to any point on this line of action. So, but in this case, I'm connecting it to AE. So I'm connecting it to AE. So you can also do for sorry, I'm connecting it to E, but you can also do for A because this particular A is also on this line of action. Note, you might be wondering that why can't I pick this particular point? Because the reason is, if we pick this particular point here, we won't be able to detect the position of this particular point. So we pick the easiest one, the one that we can easily detect its position. So that's the one we pick. That means I'm picking, like I said, I'm picking O to E in this direction. So that means my position will now be M of O to be equals to R from plus CO cross the tension of AE. Don't forget. Or you can also do you can use this particular one that I'm about to write, R of this is E, this is Z, this is C. You can also use for the one of A cross the tension of AE. So if you do this and I do this, we arrive at the same thing. So now, since we already know this is our EO, this EO means is the same thing as saying OE. So that means we need to calculate the position of this RE/O. So we are looking for the position of this. Now, how do we now go about the position of this? So this is from O to E. This particular one that I draw looks more like the resultant. So how do we go from point O to point E? So we can actually go in this manner and this manner. Are you with me? This manner. So that's how we go. Because from O to here and from here to this particular point. So let's put that down. You pick here. That means we are coming from here to here. So that means we are from O to this particular point X. We are going towards the positive of X. So that's 0.12 in I direction. Then we are coming from here to here. As you can see, we are not going towards the Y direction. We are not going in this particular upward direction or in this particular downward direction. So we are going parallel with our X axis, our Y axis. So that means we'll be having 0 in J direction. And also for our Z axis, we are coming in this direction, which is the positive side, plus 0.12 in K direction. So that means our R of E/O should be equals to 0.12I plus 0J plus 0.12k. So that means our vector our moment about O will be the same thing as will be equals to this. So we'll be having R cross F. So that means I'm using E of who? A of V. So which will be the equals to this in matrix form. You can express it in matrix form IJK. So that means we will be having our O, which is 0.12, 0.12, then our tension, which is 315 minus 240 plus, sorry, this is 180. So the moment about this particular, about point O, about our O, will be the determinant of this particular matrix. So that means we can say MO. So let's use calculator to calculate the determinant of this particular matrix. So that means we will be having, so let's set this sheet mode 6, then mate 3 by 3. So that means, okay, sorry. Oh yeah. So we look for this determinant of this particular matrix, but not in matrix form, because this is in vector form. Adding B, we are dealing with scalar products. That means we use it in matrix form. So let's do this. Split this. So that means if we pick our I, so that means we are not picking anything in this direction, anything in this direction. So that means we are having minus 240 times 0.12, 240 times 0.12, which is minus 28.8, minus 28.8 in I direction, plus, sorry, this will be minus J into bracket. So if we pick this particular J, that means we are not picking anything here, we are not picking anything here. That means we'll be having 315 times 0.12 minus 0.12 times 180. So that means 315 times 0.12. So that's 37.8 minus 0.12 times 180. That means we'll be having 21.6 in J direction. And also for our K plus K into bracket. So that means since we pick K, that means we are not picking anything here and also in this direction. So that means we'll be having 0 plus, that's minus 0.12 times 240. That's 28.8 in K, in K direction. So that means our moment about to will be equals to minus 28.8 in I direction. So that means 37.8 minus 21.6, which is minus 16, minus 16.2 in J direction plus 28.8 in K direction. So that means our moment MO on corner E will be this. Are we good? So that means if you want to calculate the moment on corner A for this particular question, will be this particular this our particular answer times minus the minus of this particular answer will be the moment on this point A, on this corner A. Are we good? Minus of this, if you multiply this by minus, we get the moment on this corner A. So moment on, since we've calculated the moment of O, this particular moment of O that we calculated is on from corner A, from A to E. So that means it will be acting on corner A. So this one we calculate is for corner A, for corner E. Now for corner A, as you can see from the diagram, we know it is towards from A to E. So that means we are coming from E to A for the second one. For it to be acting on corner A, we are coming from E to A. So that means we are taking the negative of this particular moment here. That means we will be having 28.1 plus 16.2 in J direction minus 28.8 in k direction. Don't forget the unit of our moment is what? Newton meter. And this also is in what? Newton meter. Thank you very much, guys. Make sure you subscribe to my YouTube. Please turn on the notification bar. Thank you very much.